Assalamualaikum and salam sejahtera. A very good day to my respective panel and my supervisor, Mr. Fairuz. My name is Muhammad Syahmi Hakim bin Shamsuddin and my matrix number B0519100048. I am Bachelor Degree Manufacturing Engineering student BMFG, and this is my last year project, which is Optical Monochromatic Light Reflection System that been supervised under Mr. Fairuz. So let's get started. Okay, for the first part, let me introduce you to electroplating. Electroplating is a process by which metal ion migrate via a solution from a positive electrode to a negative one. An electrical current passing through the solution causes object at the cathode to be coated by the metal in the solution. Electroplating makes use of an electrical current. Okay, so the plating thickness measurement is an important part of the electroplating process quality inspection, and which ensure the quality and consistency of the electroplating product. In order to control the plating thickness, various measurement methods are needed. In this project, we will develop a novel metal plating thickness measurement using optical method employing the monochromatic red laser light. The intensity of the light is modulated and the phase relationship of the transmitter and receiver signal compare. The velocity of light is calculated from the relationship between the change in the phase and the light path. Change in the distance of the light path will determine the plating thickness to 0.001 mm. This method gives high accuracy, repeatability, and increased cycle time of measurement. Okay, next, for the problem statement, there are two problem statements in this experiment, which is inconsistency in plating measurement because of human error and equipment error, and second, high inspection cycle time. And then for the objective of this topic is to design and develop metal plating thickness measurement system using red laser monochromatic light velocity detector, and then improve the accuracy of the plating thickness measurement compared to the currently technique employed by the industry, and last, improve inspection cycle time compared to the currently technique employed by the industry. The main part for the PSM1 project is literature review. Okay, first, coating are widely used to obtain a synergetic action between the characteristic of the substrate and the covering material. They can enhance physical, chemical, and aesthetic properties and lower the cost of the final product. Second, measurement of the thickness in composite material is mandatory both to obtain the right characteristic in the final artifact as well as to keep the cost under control. Third, the tiniest measurable thickness coincides with an atomic monolayer, while the thicker layer can reach hundreds of microns in the case of electroforming. Number 4. The process can be classified into two different categories, which is destructive and non-destructive technique. Destructive technique permit the direct measurement of the thickness and require the sample to be modified at the microscopic level, while non-destructive technique facilitate the measurement of the sample without damaging it. Indirect measurement fall into the category of non-destructive technique, in which some assumption and calculation have to be performed to obtain a numerical value of the thickness. Number 7. Many destructive methods require a specific sample preparation step, while non-destructive methods are usually self-consistent and require minimal. Number 8. Destructive technique preparation method like mechanical cross-sectioning, FIB cross-sectioning, angle lapping, TEM lamella, color tester. Microscopic analysis is optical, SEM, SIM, chemical dissolution. for the non-destructive technique, they are XRF, EPMA, ellipsometry, Rutherford backscattering, spectroscopy, and resonance method. Okay, next we jump to the methodology part. So after this, I will preview a video where I meet my supervisor and he shows me the system for monochromatic light. So I will explain the device or the system in next video. In this part, I will explain about the methodology of the optical monochromatic light reflection system to determine the coating thickness. I met my supervisor, Mr. Fairuz, and he showed me the monochromatic light system. So basically, the system have a software to calibrate and calculate the measurement. Right here we have a laser, and right there we have the reflector. So the laser will emit the reflector and the reflector will get signal. In this cap, we used to put the product before coating and after coating. So the difference is the coating thickness for the product. Okay, for the flowchart, there are two flowchart in this presentation, which is system software flowchart and overall flowchart, which is for PSM1 and PSM2. Okay, for the system software flowchart, when the system is switched on, the system need to be calibrated. Second, it depends an acquisition spectrum of reference mirror or within quartz glass. Third, the system will make comparison of central wavelength. And then fourth, the system will calculate thickness of quartz glass, meanwhile refer to aberration correction or error correction. Okay, and then for the overall flowchart, in the left part, it is the task for PSM1, which is literature review, determine specification, software and hardware development. On the other hand, it is the task for PSM2, while will conduct and manufacture the project like simulation and testing, data collection, analyze data result, and reporting writing. But if the data that given is not accurate, we will repeat this step until we get the accurate data. So it's easy to write the report. So the expected result that I expect for this project is first to get the accurate result of the measurement coating thickness, and then high sensitivity measurement for the system, and third, minimize parallax error or human error or reading error. The challenge that I get while manage the project is the reflector does not work perfectly, so it will affect the measurement. Second, limited sample product before and after coating. Third, periodic calibration on the sensor. And fourth, the laser always need to be adjusted in certain position. So in this opportunity, I want to thanks to my supervisor to help me complete the PSM1, and thank you for respective panel, and bye.